Hello everyone, my name is Susan Kumar Dinesh Bhai Patel and today I will discuss you about MHF4U Unit 4 Mid-Unit Assignment. Fourth number. The regular motion of the Earth about the Sun causes the daily change in the high temperature at any location on Earth. The chart and the graph shown are the daily average high temperature in degrees Celsius for each month in Yellowknife and WT compiled for several years. Determine the trigonometric equation that models this information. Let y be the temperature in degrees Celsius and x be the numerical value of the month. From the question we take the trigonometric equation as y is equal to a sine b x minus c plus d, and we give that equation name as equation A. Above the equation A is equal to maximum minus minimum divided by 2 in temperatures. So A is equal to 21 minus in bracket minus 24 divided by 2. Therefore A is equal to 45 divided by 2, which is equals to 22.5. From the graph we know that the period is equal to 12 months. So we take period is equal to 12. Now B is equal to 2 pi by period. We know that period is equal to 12, so we put 2 pi by 12. We get pi by 6. Now, sine value at 3 pi by 2 is low, so we take as pi by 6 in bracket 1 minus c is equal to 3 pi by 2. So 1 minus c is equal to 3 pi by 2 into 6 by pi. As we evaluate this equation, we get 1 minus c is equal to 9, so c is equal to minus 8. Now d. D is equal to maximum plus minimum in temperatures divided by 2. D is equal to 21 plus in bracket minus 24 divided by 2. So we get D is equal to minus 3 by 2. Therefore, D is equal to minus half. As from the graph, January is the coldest month and sine heat is at 3 pi by 2, which is lowest point, and whereas July is the warmest month and heat of pi by 2 is highest month. Evaluating the above values in equation A, we get y is equal to 22.5 sine pi by 6 in bracket t minus minus of 8 bracket close minus 1.5. So we get our main equation y is equal to 22.5 sine pi by 6 t plus 8 minus 1.5, which is our final equation. Second number. A Ferris wheel has a diameter of 10 meter and takes 24 seconds to make one revolution. The lowest point on the wheel is 1 meter above the ground. So the figure will come like this. There is the ground and 1 meter above it is a Ferris wheel. A. Sketch a graph to show how a rider's height above the ground varies with time as the Ferris wheel makes a rotation. Assume the person starts the ride at the lowest point on the wheel. B. Write a trigonometric equation that describes the graph. C. Check the accuracy of your equation by using t is equal to 12 seconds. Explain why this provides a check of the accuracy of the equation. What are the two more values that will provide a good check? Now let's start our second number answer. From the question, the diameter is 10 meter, so the radius will be 5 meter. For complete one revolution of Ferris wheel, it takes 24 seconds. 1 meter is the lowest point above the ground. So, from the given above positions, the equation will be y is equal to a sine b in bracket t minus c plus d, which gives our equation A. From there, A is equal to maximum height, that is radius of our Ferris wheel, which is equal to 5 meter, and D is equal to maximum height plus 1 meter above the ground. As maximum height is equal to 5 meter plus 1 meter, that is 5 meter plus 1 meter, which is equal to 6 meter. Now T is equal to time. Period of sine x we know as is equal to 2 pi. So y is equal to a sine b in bracket t minus c plus d. For finding b period, one complete revolution we take 2 pi, that is equal to 24 seconds. So 2 pi by 24 will give us 12 by pi. But inverse of the period 12 by pi is b. So we take which is pi by 12. So we get our new period b is equal to pi by 12. Now c is equal to phase shift, which is c is equal to 6 seconds. Evaluating all above values in equation A, our main equation, we get y of t is equal to 5 sine pi by 12 in bracket t minus 6 plus 6. Now A. Sketch a graph. Time was height. Time second in t and height in meter. 6, 6, 12, 11, 18, 6, 24, 1 and 36. So the graph will be like this. 6, 6, 12, 11, 18, 6, 24, 1 and 36. So this is our final graph. Now B. B is a right trigonometric equation. So according to the question, the trigonometric equation will be y of t is equal to 5 sine pi by 12 in bracket t minus 6 plus 6. C. By evaluating the value of t is equal to 12 seconds in equation A, our main equation, for check of accuracy of our equation. So therefore y is equal to 5 sine pi by 12 t minus 6 plus 6. Therefore y is equal to 5 sine pi by 12 minus 6 plus 6. So therefore y is equal to 5 sine pi by 12 in bracket 6 plus 6. So therefore y is equal to 5 sine pi by 2 plus 6. Now therefore y is equal to 5 into 1 plus 6 because sine pi by 2 is equal to 1. So therefore y is equal to 11 meter. This will give us an accurate check. Now the value we get from the equation is 1 for both value at t is equal to 0 as well as t is equal to 24 seconds, and so it will provide an accurate check. Third number. The height of the tide in the Bay of Fundy relative to pier varies from a low of 4.5 meter at 208 and to a height of 17.3 meter at 8.21, measured within a 24-hour clock. A. Assume that the height h of the tide can be modeled as cosine function of the tide of day t, and then determine the equation in the form h of t is equal to a cos in bracket k in bracket t minus t bracket close plus c. B. Where h of t is the height of the tide at the pier in meters and t is the time of day in hours. C. Determine the height of the tide relative to pier at 11:30 and give your answer to nearest 0.1 meter. D. A boat needs a depth of at least 12 meters to dock at the pier. Use the graphical approach to determine when the boat is able to dock and when it must leave. So the answer of third is the height of a low tide is 4.5 meter at 28 and the height of the high tide is 17.3 meter at 821. A. H of t is equal to a cos in bracket k in bracket t minus d whole bracket close plus c. As h of t is equal to height of tide, a is equal to maximum height minus minimum height in meters divided by 2. So a is equal to 17.3 minus 4.5 divided by 2. So a is equal to 6.4. C is equal to maximum height plus minimum height divided by 2. C is equal to 17.3 plus 4.5 divided by 2. So C is equal to 10.9. Now D. D is equal to phase shift, which is equal to 8.35. We take 2.08 is equal to 2 plus 0.8 by 60. So 2 plus 0.1333. So we get 2.133. And 8.21 is equal to 8 plus 21 by 60, which is equals to 8 plus 0.25, which is equal to 8 plus 8.25. Now period is equal to 12.44. Implies k is equal to 2 pi by period. As we know that period is equal to 12.44, so we take 2 pi by 12.44. We get pi by 6.22, which is equals to 0.505. So we get k is equal to 0.505. B. According to the question, the equation will be h of t is equal to minus 6.4 cos in bracket 0.505 in bracket t minus 8.35 whole bracket close plus 10.9. C. At t is equal to 11:30, which is equals to 11 plus 30 by 60, which is equal to 11.5 hour. Evaluating the value of 11.5 in above equation, we get h of t is equal to minus 6.4 cos 0.505 in bracket 11.5 minus 8.35 whole bracket close plus 10.9. So h of t is equals to minus 6.4 cos 0.505 in bracket 3.15 bracket close plus 10.9. So therefore h of t is equal to minus 6.4 cos in bracket 1.58 plus 10.9. So h of t is equal to minus 6.6064 plus 10.9. Therefore h of t is equal to 10.8 meter. Therefore the height of the tide relative to the pier at 11:30 is 10.8 meter. Now D. Evaluating the value of h is equal to 12 meter in the equation, we get, therefore 12 is equal to 6.4 cos in bracket 0.505 bracket t minus 8.35 bracket close plus 10.9. Therefore 12 minus 10.9 is equal to 6.4 cos in bracket 0.505 bracket t minus 8.35 bracket close. We get 1.1 divided by 6.4, as the value of this is 1.1 and the division will come 6.4 as it is in multiplication. So we get 1.1 divided by 6.4 is equal to cos in bracket 0.505 bracket t minus 8.35 bracket close. Therefore 0.172 is equal to cos in bracket 0.505 bracket t minus 8.35 bracket close. Therefore cos inverse is equals cos inverse 0.172 is equals to 0.505 in bracket t minus 8.35. Therefore 1.398 is equal to 0.505, that is in bracket t minus 8.35. Therefore 1.398 divided by 0.505 is equals to t minus 8.35. Therefore 2.768 is equals to t minus 8.35. So we get 2.768 plus 8.35 is equal to t, and we get t is equal to 11.12, that is h is less than or 12, so t is equals to 11.07 r. Therefore the graph which gives us boat is able to dock and leave is this, which is the midpoint is 6.4, this, the point is 5.5 the entrance of the boat and 11.12 leaving point of the boat, and again 18.02 is the entrance of the boat and leaving point is 23.56. So these all are the graph's points, and this is the time where the boat will enter as well as leave. This is our main graph for the boat entering as well as dock and leave. Thank you and have a nice day.